Now in class 11th, I will start a new chapter, the motion in a plane. Motion in a, this is the name of the chapter, and now topic that we are taking here is the position vector, and the displacement vector, the velocity vector, and the acceleration vector. Acceleration vector. This is the topic. Up to now you have studied about the motion in a straight line. So that is one-dimensional motion. And now in this chapter you will study the motion in two dimensions. Motion in a plane is motion in two dimensions. Motion in 2D. 2D is two dimension. Two dimension where we are having the xy plane, yz plane, or xz plane. Then this is called the two-dimensional motion. Or if it is a circular motion, that is also a two-dimensional motion. So here the whenever if similarly the projectile, that is also a two-dimensional motion. So here we will take only the two-dimensional motion. So first I am taking the position vector. What is the position vector? This is the position vector. Position vector. The vector which represents the position of a particle in two dimensions or three dimensions is called position vector. Position vector. Here we will take only the two dimension, like generally I have taken the three dimension. When we are given x, y, z, then we can express in the three dimensions also. So now let us take in two dimension. This is now your x, this is y, this is the point P. It has the coordinates x, y, and just we join to this with the origin, then this is called the position vector. OP is the position vector. And now you can have this and this. This is now OP, this suppose now this Q. So what we have that this is the so much is the y and this so much is the x. So we will have that this is now y and this is now x. Consider the point P x y. So a triangle law of vector addition. What we have, this OP, this is equal to OQ plus QP, OQ plus QP. If we take this as here, this is now so much in this direction. So what we have is OP, that is equal to R. OQ, this is now your x, and here we take the unit vector I, and here we take the unit vector j. This is now your j. So we can write it to be x I plus y j. So what we have, this R equal to xi plus yj. This is now position vector. And now you can see that the magnitude of this one, this is equal to square root of x square plus y square, or we can write it to this R equal to square root of x square plus y square. This is not so much. This is the magnitude. Now if you just suppose this angle is theta, then we can have tan theta is equal to PQ upon OQ. PQ perpendicular upon base. So this is equal to your y upon x. This is equal to tan theta. So this gives you that theta equal to tan inverse y upon x. This is like this one. So this we have represented in the 2 dimensions, and if we are having suppose 3 dimensions, in this R equal to is xi plus yj plus z, और अगर हम इसका मैग्नीट्यूड निकालें, दिस इक्वल टू स्क्वायर रूट ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर plus z square. So this is the magnitude. So if we express in 2 dimensions, then we are having this one. If we express in 3 dimensions, then this is equal to so much. So this is what the position vector of the point P. So it represents the position in the space where it is located. So this we have taken the x, y in the 2 dimensional representation of the position vector. Now let us take the displacement of it. Displacement. Now that we are having this xy plane xy plane. Suppose here this is now your point P1. Another point is here. This is now suppose Q. So this is like this. This is suppose R1 and this is suppose R2. Then this is equal to your position vector that we take. This is not displacement vector, delta. So again having let the coordinates of this P point is equal to P1 x1 y1 and it has your x2 and y2. These are the coordinates. The coordinates of P1 x1 y1, coordinate of PQ that is x2 y2. So now we can have this R1 equal to x1I plus y1j, R2 x2I plus y2j, and then just to apply the law of vector addition. Using law of triangle of vector addition. What we have that this your R1 plus delta R, this is equal to R2. So this delta R, this is equal to R2 minus R1. So this delta R, this is equal to x2I plus y2j minus x1I plus y1j. So just to solve to this one, you will find this x2 minus x1I plus this is now your y2 minus y1j. So this is what? This is now your delta x I plus delta y j. So this is so much delta. This is a position vector, displacement vector. This is a displacement vector where delta x where delta x equal to x2 minus x1 and delta y is equal to y2 minus y1. So now if we have this to be, now suppose this is your delta x and this is delta y, then this will be the delta r. This is not like this. This is now suppose angle theta. Then you can have the magnitude delta r. Its magnitude equal to square root of delta x square plus delta y whole square. You write down like this, more better. This is not so much. And if you find the tan theta equal to delta y upon delta x, or this theta equal to tan inverse delta y upon delta x. This is equal to so much. So this is what the displacement vector. So we are taking the 2 points. Now this point P is displaced to this point Q point Q, where this the coordinates are x1 by 1 4 point P and x2 by 2 4 point Q. So now this so much is the displacement that is produced when the particle moves from P to Q. So this is the displacement vector. Now we take the velocity vector. This is the velocity vector. Velocity vector. Now we go to this delta. We know delta R is equal to delta xi plus delta yj. This is not so much. Now definitely this particle is taken some time from P to Q. So dividing both sides, by delta t, the time interval. This is what? The time interval. So what will we get? This delta R upon delta t. This is equal to delta x upon delta t I plus delta y upon delta t into j. So we will have this is equal to V is equal to Vx I plus Vy j. So what we are having? This is now your velocity vector, where Vx equal to delta x upon delta t. Vy equal to delta y upon delta t. This is the velocity component in x direction, this is the velocity component in y direction. So we have to this is now suppose your Vx, this is suppose Vy, and then you join to this one, that is equal to now V. Let this makes an angle theta. So what we have, that the magnitude of V, this is equal to square root of Vx whole square plus Vy whole square. This is the magnitude. And that direction that we can take, tan theta equal to Vy upon Vx, or this theta equal to tan inverse Vy upon Vx. This is equal to so much. So you can find the direction and you can find the magnitude and the velocity vector also. So this gives you the velocity vector. Now then we are having the acceleration vector. Acceleration vector. Acceleration vector. So now we know that whenever there is a change in the velocity, then there is a velocity vector. So now here the velocity vector, and that we know that v equal to vxi plus byj. So change in velocity. Change in velocity. This delta v is equal to delta vx I. This is delta vyj. Change this. Let this change takes place with the in the time delta t. Dividing both sides by delta t, time interval. So what we have is delta v upon delta t is equal to delta vx upon delta t into I plus delta vy upon delta t into j. So this is now velocity. So this is now acceleration. So acceleration A is equal to, this is now ax I, this is plus ay j. This is now your acceleration vector, where delta v upon delta t is equal to a, and this delta vx upon delta t, this is equal to ax, and delta vy upon delta t, this is equal to ay. So then you can represent it in the form of a triangle. This is now so much. This angle is theta. This is now your ax. This is ay. Then this is a. So just you can have the magnitude of this one. This vector a magnitude equal to square root of ax square plus ay square. This is not magnitude. And then you can find the acceleration, or that its direction. Now you can have the tan theta. Tan theta equal to ay upon ax. Ay upon ax. So from here we are having this theta equal to tan inverse ay upon ax. This is so much. So this is necessary to have the knowledge in the two dimensional, that how to find the position vector, displacement vector, and how to represent them, and how to find the magnitude, because this will be used in the later topics of this motion in a plane. So this is, I have taken the initial elementary representation of the position vector, displacement vector, velocity vector, and the acceleration vector. Thank you.